Children, let us continue the chapter circles. Now let us discuss about the statement and proof of the theorem 2, which is on the tangents of the circle. You know that tangents from the external point to a circle are always equal. This is the statement of the theorem 2. What is the statement? The statement of the theorem 2 is length of the tangents from a external point to a circle are equal. And by measuring, we got the result. Now let us prove this theorem logically. So here the statement of the theorem is length of the tangents from a external point to a circle are equal. Now let us discuss about the proof. So you take the proof here. And what is given here? We are given a circle with center O. Here O is the center of the circle. Circle is given with center O. So what is given? You note down. We are given a circle with center O. We are given a circle with center O. And which is the external point here? Here what you have to prove? Length of the tangents from an external point to a circle are equal. Yes, we got a circle here and there is a point which is external point here. There is a point P. So you take P is a point lying outside the circle. Outside the circle. So it is a external point. P is a point lying outside the circle. So it is a external point with respect to the circle with center O. PQ and PR are the two tangents from the external point P. And also you note down that one. PQ and PR are two tangents on the circle from the point P. So what you have taken here? PQ and PR are two tangents on the circle from the point P. Now what you have to prove? We need to prove that So what you have to prove? Tangents are equal. Which are the two tangents here? PQ and PR are the tangents from the external point P. What you have to prove? We have to prove that they are equal. So you write PQ must be equals to PR. So what you have to prove? PQ equals PR. We have to prove that PQ equals PR. Now here there is a necessity of construction. We have to prove with the help of the previous knowledge. That is also with the help of the congruency of triangle. So to take two triangles, here we have to join the radii OR and OQ. Join the radii OR and OQ and also join OP. So what is the construction that you have to do here? Join OQ, OR and OP. Now let us do the construction, that is join OQ, OR and OP. Here we joined OQ, OR and OP. Now you got two triangles. So write the construction here. Let us join what and what? Let us join OP, OQ and OR. OP, OQ and OR. Now we got the radii OQ and OR. And OQ is the radii at the point of contact of the tangent PQ and OR is the radii at the point of contact of the tangent PR. Here Q and R, they are the point of contacts, and the angle between the radii and the tangent must be equals to 90 degree. Angle between the tangent and the radius at the point of contact is equals to 90 degree. So you got two right angles, angle OQP and angle ORP. So triangle OQP and triangle ORP are the right angle triangle. Now let us prove that two triangles are congruent. Naturally, we will get PQ equals PR. Now, let us write here angle OQP and angle ORP. Angle OQP and angle ORP are the angle OQP and angle ORP are the angles between the radii and tangents. Between the radii and tangent. Therefore, you can say that you can write angle OQP and angle ORP are right angles. Right angles. Now you take the two right angle triangle OQP and triangle ORP, and prove that they are congruent. Here you give the reason, that is theorem. Read the previous theorem, that is theorem 1, previous theorem. Angle between the tangent and the radius at the point of contact is 90 degree, means the radius at the point of contact is perpendicular to the tangent. Next, you take now in right angle triangle, in right triangles OQP and ORP. So you take the triangle OQP and ORP. You know that here angle Q is equals to angle R, and they are 90 degree, and OQ is equals to OR. Why OQ is equals to R? You know that they are the radii. The radii of same circles are always equal. And next also you can write OP. Here OP is a common side of the triangle OQP and ORP. So you can write OP is equals to OP. Then you can say that according to the RHS postulate, RHS congruence rule, you can say that triangle OQP is congruent to triangle ORP. So you write in the right angle triangle OQP and ORP, write OQ equals OR. Reason, radii of the same circle. Radii of the same circle. Radii of the same circle. And also you write OP is equals to OP. OP is equals to OP. Why OP is equals to OP? That is the common side. That is the side of both the triangle. So you can write common side it is. Common side. So here in a right angle triangle, hypotenuse and a side of one right angle triangle are equals to the corresponding side and hypotenuse of the other triangle, then those two triangles are congruent. So you can write that, therefore right angle triangle OQP is congruent to right angle triangle ORP. So which congruence rule is used here? RHS congruence rule. RHS congruence rule. And once you got that the two triangles are congruent means all the corresponding parts are equal. Therefore, you can say that PQ equals PR. That is according to CPCT. Therefore, you write, therefore, PQ equals PR. Reason here CPCT. Reason is CPCT. In this way, we proved that length of the tangents from a external point to a circle are equal. PQ, PR are equals, and they are the tangents from the external point, and we got that they are equal here. Logically, we proved this theorem. Now, let us prove one of the important result which is based on the two theorems, theorem number 1 and theorem number 2 on the tangents with respect to the circle. And this is one of the important question in the examination point of view also. Now, let us see the question. What is that question? Two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that angle PTQ is equals to 2 angle OPQ. Angle PTQ is equals to what you have to prove here? 2 angle OPQ. Now, you take down what is given here. What is given? So, let us have the solution. We are given a circle with center O. Circle with center O. Here it is given that O is a circle, O is the center of the circle, and PT and QT are the two tangents from the external point T. So you take TP and TQ are the two tangents from an external point T. External point T. And here what we have to prove? We have to prove that angle PTQ is equals to 2 angle OPQ, and P and Q are the point of contacts here. T is an external point. TP and TQ are the two tangents from T to the circle. From T to the circles here. To the circle, and P and Q are the point of contacts. P and Q are the point of contacts. P and Q are the point of contacts here. Now what you have to prove? We have to prove that angle PTQ is equals to 2 angle OPQ. We need to prove that angle PTQ equals to angle OPQ. Angle PTQ equals to angle OPQ. Now let us denote angle PTQ. Angle PTQ equals X. Let angle PTQ equals X. And also you know that TP is equals to TQ according to the theorem that you have proved previously. So you take TP is equals to TQ. Tangents from the external point are equal. That is a theorem that you have proved. Tangents from the external point are equal. So as TP is equals to TQ, triangle TPQ is an isosceles triangle. So right, therefore in an isosceles triangle, TPQ, in an isosceles triangle TPQ. Why triangle TPQ is an isosceles triangle? Here the two sides TP and TQ are equal, therefore it is an isosceles triangle. So you take, in an isosceles triangle, you write here angles TPQ must be equals to angle TQP. Angle TPQ must be equals to angle TQP. They are the angles opposite to the equal sides, as TP is equals to TQ, and they must be equals to 180 minus angle T by 2. Therefore you write angle TPQ equals angle TQP. Angle TPQ equals angle TQP. They are equals to what? Equals to 1 by 2 of 180 minus x. That is, x means angle PTQ. Angle PTQ, 180 minus angle PTQ by 2, or 1 by 2 into 180 minus x, that equals 1 by 2 into 180 is, that is 90. So 90 degree it is, minus 1 by 2 into x is x by 2, you can write x by 2 it is. Now consider this is the first year, and you know that what is the measurement of the angle OPT. This angle OPT is 90 degree. Why it is 90 degree? Here OP is a radius at the point of contact of the tangent TP. OP is a radius at the point of contact, and OP must be perpendicular to TP. So you can write angle OPT is equals to 90 degree. That is, OP is perpendicular to TP. So what you can take here? OP is perpendicular to TP. That is the theorem, previous theorem that you have learnt here. Radius at the point of contact is perpendicular to the tangent. You can write radius at the point of contact is perpendicular to the tangent. That is OP perpendicular to PT here. Now therefore you can write that here you need the angle OPQ, and OPQ is nothing but angle TPQ, this whole angle, minus angle this angle TPQ. That is OPQ is equals to what? OPQ is equals to angle TPO minus angle TPQ, right? So you write angle, which angle? TPQ is equals to angle TPO or OPT. You take angle OPT minus angle, which angle? TPQ. TPQ. So that is equals to, you know that OPT is 90 degrees. So you take that is second here. That is second. And TPQ that you got here. So you write OPT is 90 degree minus TPQ is 90 minus x by 2. That is what? From first and second it is. From first and second. Therefore, angle TPQ is equals to 90 degree minus, open the bracket here, 90 degree minus of minus becomes here plus x by 2. Therefore, you write angle TPQ is equals to 90 cancels. What it becomes? X by 2. TPQ is equals to x by 2. X we have taken angle PTQ. Therefore, you can write angle TPQ is equals to, what is that? Angle PTQ by 2. That is nothing but, you do the cross multiplication, 2 into angle TPQ is equals to angle PTQ. That implies angle PTQ is equals to angle TPQ. To angle TPQ. In this way you got the result here. So what you have to prove here? That you have proved here, angle PTQ is equals to angle OPQ.